location in Bunker Hill, and Sarah Blount, our conservation technician for the watershed, is located with those folks today. So thank you for joining us down there. Also want to acknowledge that we have Gene Brokish from American Farmland Trust working in the background, and also we're joined today with several of our partners. We could go to the next slide. Just want to mention a few Zoom tips for you today. And for those that haven't been on Zoom before, please feel free to use the chat function to ask questions. We'll have hopefully an ample amount of time at the end of the program today for some Q&A. So please use that function throughout the program. Next slide. Also, if you'll notice down in the lower left-hand corner, you can unmute yourself during the Q&A session, and also use the video function there as well. This program is being recorded for future use, so just want to acknowledge that recording has already began. Next slide. So on behalf of American Farmland Trust, just want to again welcome everyone here today. And for those that aren't familiar with American Farmland Trust, we're a national nonprofit organization that's working to protect farm and ranch land throughout the United States, promote sound farming practices, and also keep farmers on the land. And our tagline, some of you may recognize it, is "No farms, no food." You may have seen some of those bumper stickers on the back of grain trucks or vehicles throughout the state. Next slide, please. The Upper Macoupin Creek watershed, just want to mention a little bit about that, because American Farmland Trust and 15 other partners have been working in this watershed for the last several years. The watershed is located in Macoupin County. It's about 138,000 acres. Of that, about 62% of the watershed is row crop agriculture. It was also identified in the 2015 Illinois Nutrient Loss Reduction Strategy as one of the top phosphorus loading watersheds from non-point sources. And so we have been working alongside partners, local partners, and others in that watershed for the last several years to bring additional technical and financial resources to this location. And again, just want to mention, I think I forgot to mention my name. I am Chris Reynolds. I'm the Midwest Regional Director for American Farmland Trust, and I'm located just to the east of Macoupin County, over in Montgomery County, and have been working in conservation in this area for the last 20 plus years. So excited to be here today to talk a little more about nutrient management and some of our work in this watershed. Next slide. So a lot of what we're going to talk about today is part of our core conservation practices that we're promoting within the watershed. So we identified these three practices: nutrient management, strip till and no-till, and cover crops, as the top three priority practices that will help us reach the goals of the nutrient loss reduction strategy, and also reduce non-point source phosphorus loading from agricultural fields. These practices were also identified in the nutrient loss reduction strategy as having a major impact in nutrient loss reduction, helping farmers keep their nutrients on the land where they can be utilized for crop production. And next, I'll introduce our presenters today. Dr. Tony Vine is joining us from Purdue University, and Dan Schaefer is with the Illinois Fertilizer and Chemical Association, and Bill Hyan is joining us from the watershed itself, and he's a Macoupin County farmer and Upper Macoupin Creek Watershed Steering Committee member as well. And I'll do some formal introductions as we introduce everyone. So at this time, I'm going to let Dr. Tony Vine share his screen, and I'll do a quick introduction. So Dr. Vine, thanks for joining us today. He is a professor and cropping systems extension agronomist in the Department of Agronomy at Purdue University. Tony grew up on a hog and cash crop farm near Ridgetown in southwestern Ontario, Canada, and he earned his degrees from the University of Guelph after studying biology for 2 years at Trinity Christian College in Chicago. He was a faculty member in the crop science department at Gulf from 1987 until he joined the faculty at Purdue University in 1998. He was named the Corteva Agriscience Henry A. Wallace Chair in Crop Science at Purdue in 2018. And he advises graduate students in research focused on understanding the interactions of tillage, crop rotation, plant density, and nutrient placement systems with corn response and soil properties. He has been investigating and promoting strip till systems for over 25 years, and Tony has served as co-chair of the Indiana Crop Advisor Conference since 2003. He and his wife are blessed with 4 children who live with their respective families in the United States and Canada. So, Dr. Vine, thank you for joining us today, and I will turn it over to you.
Well, thank you very much for that kind introduction, Chris. And this is an opportunity to visit with farmers and other interested parties in the Macoupin watershed, as well as perhaps those of you who are joining from other watersheds in Illinois. I'm going to provide a bit of an overview on a system that is near and dear to my heart, as well as to my science, and that is essentially the system that I've advocated for a long time now, which is strip tillage. And so today's presentation is all about looking at individual examples of opportunities to improve yields, deal with the question of nutrient efficiencies in strip till, and infer from these opportunities what the prospects are for improving environmental quality. And I welcome the panel discussion, as well as welcome the opportunity to have other things, other opportunities for dialogue with the other speakers this morning as well. I would like to begin by essentially saying there is both short-term and long-term data which argues for the success of the strip till system. Now, it is fair to say that most of the research on strip till systems has been done for fields that are less than 5% in slope. And so there is a limit, especially in a fall strip tillage system, for the successful implementation of strip till, because it's also the case that if you were to try to do fall strip tillage when you have fields that exceed 5, let's say going up to a 10% slope, which would be very steep, that there is unfortunately a prospect for losing soil. But let's just say, for the most part, our fields are less than 5%, and in that regard, we need to know a little bit more about just what the prospects are for strip till. And I'm going to be focusing mostly on the prospects for corn. And there is also, of course, a lot of simultaneous work that I and others are doing with strip tillage for soybeans, although in this case, it's for wide row soybeans in 30-inch rows. It is essential to always be thinking about the RTK system when we're looking at strip till. In the early days of strip till, it was trying to do the best job possible with guidance systems that weren't nearly as good as those that we have today. In our long-term tillage plots, we've been looking at tillage responses in continuous corn and the corn-soybean rotation, as well as in continuous soybean. And these are located near West Lafayette, near Purdue University. And this is an experiment that is still continuing today. We look at yields, but we also look at properties. I'm going to deal with yields in a moment, but I just wanted to introduce one thing to think about whenever we think about nutrient placement in a changing tillage system. And I've chosen in this particular case to start with potassium because it's relatively an environmentally innocuous mineral, and it is not associated with a water quality problem or an air quality problem that we know of today. But in any case, I just wanted to introduce the concept of nutrient stratification and what we are doing with our tillage systems whenever we combine, let's say, a normal broadcast application, because that is sort of the historic thing that we've been doing. So in this particular long-term tillage practices, we've been looking at moldboard plow, and in this particular case, we're just looking at potassium concentrations. These are in parts per million. At the 0 to 2 inch depth, 2 to 4 inch depth, 4 to 8 inch depth, and 8 to 12 inch depth. So in other words, we're stratifying. Now, in Indiana, it's fairly common to take soil tests down to an 8 inch depth, and that is not the case in many other states, which only sample down to a 6 or a 7 inch depth. But in any case, what I wanted you to know, first of all, was with the moldboard plow, just how consistent that potassium concentration is at around 200 parts per million down to the 8 inch depth. With chisel plowing, I wanted you to notice the stratification that occurs. And the same thing is true with what historically was a ridge till system, and which for the last 11 years now has been a strip till system. So it's quite stratified in terms of potassium if you use a broadcast application program. And it's most stratified in the no-till system. And the reason I want you to think about this is that if you are, let's say, married to a vertical till program today, or you're married to a disc chisel system today, then what you're going to start with is quite a stratified fertility situation for both phosphorus and potassium. Phosphorus is even more tightly bound to soil than potassium is, and so the concentrations close to the surface are going to be even higher. So if you're thinking of going to a wholesale program, which has not just the tillage aspect to it, but also a nutrient banding, you want to be thinking a little bit about where the nutrients you want to band are being placed and whether they are essentially being placed right at the surface, which is already high in P and K, or whether they are being placed at deeper depths where perhaps there may be more benefit. And so this is a function of the resources that you have available to you, and the particular type of tillage machine that you either rent or use as in a custom application program. So let's just go a little bit on yields. And so I've chosen here to, out of those 4 tillage systems, to just focus on 2. And so the purple is the strip tillage corn yields that we've had since 2012, our drought year, a year in which Indiana corn yields only averaged 99 bushels per acre. And essentially what I wanted to show is that even if there is no nutrient banding in a strip till program, it compares very favorably to the chisel plow system and usually has yields at least as good as the chisel plow system, and sometimes around 10 bushels better. So strip till by itself has the opportunity to give you a yield benefit compared to a full width tillage program. So by itself, strip till is already providing the benefit of the residue protection between the rows, and by itself, it's already given you the opportunity to do planting as the first operation in the spring. The lighter colored bars here are for the continuous corn program. But again, the lighter chisel plow is shown here in green, and the lighter strip till is shown here in purple. And again, what I want to emphasize is that even in a continuous corn program, and I understand in your county that's maybe less than 5% of the total corn that's grown. But in any case, for those of you who are concerned about adopting strip till because, well, I grow corn after corn on some of my acreage, you should rest assured that strip till is reliable even in a corn after corn program. Although it is fair to say that yields will be lower in the corn after corn than they are in the corn after soybean. So this slide essentially just shows the difference in yield for strip till corn after soybeans versus strip till corn after corn. And as you can see over here with our system that we have, that's about a 20 bushel difference. All of these yields for this silty clay loam soil with about 4% organic matter are available online at the website. And if we were to look at things over, let's say, a 9-year period, this is again strip till in purple. And you can kind of see what the yield results are, about 225, a little bit better than the chisel plow, equal to the moldboard plow yields, and a little bit better than no-till alone. And once again, there is a superiority of the strip till system in continuous corn compared to the no-till system. So we're fairly sure on yield. So one of the lessons here is an RTK guided strip till. As long as we are following that loosened strip, we can get corn yields equal to those of fall chisel and corn after corn and corn after soybean. I should, though, really emphasize that there may be an opportunity to do even better if we factor in the opportunity to plant earlier with the strip till system than we do in a no-till program, or than we do in a full width tillage program, where you have to wait for the soil conditions to be fit to do the secondary tillage or to do the vertical tillage that you might want to do in the springtime of the year. If you have fall strip till, the soil is quite friable in those strips, and it allows for an earlier planting opportunity. So when I talked about the yields earlier, that was with the assumption of we're planting the same hybrid at the same plant population on the same day. If you were to factor in the additional opportunity for even earlier planting, those yields might have been even better. Now let's deal a little bit with not just the straight physical effect of the opportunity to get higher yields with that loosening, where you plant onto that loosened and somewhat drier berm in the springtime. And that is, should we be thinking about reducing our rates of phosphorus and potassium fertilizer if we have the opportunity to ban nutrients at the same time as doing the strip tillage operation itself? As far as I know, there's only one state that argues for a lower banding rate with phosphorus, and let's say the dominant concern in this workshop is with phosphorus. So let's just look at what they recommend here. And basically, they're suggesting that the pounds of P2O5 for a very low testing soil would be 65, whereas with broadcasting, you'd need 130 pounds in order to get the same yield benefit. And here is a medium testing soil where they're suggesting, okay, for corn, a 30-pound rate versus a 55-pound rate of actual P2O5. So this is, and here by medium testing soils, They mean 8 to 11 by Olson and 11 to 15 by Bray, which is, very similar to what we would have with, let's say, a Mehlich 3 extracting. So, some of these numbers depend on which lab you're actually using and what test they actually use. Now, in states like Illinois and Indiana, there is no similar standard recommendation that you can actually lower your rates if you were to ban compared to broadcasting. So I don't want to hold out the hope for you that if you were to make a wholesale conversion into strip till and then you were to say, well, okay, I'm going to buy a strip till machine, and at the same time, I'm going to buy a dry fertilizer applicator, and I'm going to save on my fertility costs by lowering the rate of phosphorus that I might apply, whether it's MAP or DAP. So, I just wanted to kind of introduce this a little bit gently because of the fact that there is quite a large, I would say, incentive, like financially, with higher fertilizer prices, especially in the last year, driving perhaps a consideration of, well, maybe we should think about reducing the rates, because after all, if we're applying this dry fertilizer product, aren't we putting it right where the row will be planted? And I can see intuitively that would be attractive. I can see intuitively that would be particularly attractive if you're in a situation where you have limited or no starter fertilizer capability on the planter itself. So in our research, we've looked at strip tillage plus nutrient banding, and in the early days we were using a shank type implement in order to get to deeper depths of 7 inches with the fertilizer application. And more recently, we've been looking with the environmental tillage system unit called the Soil Warrior, and you've probably seen these around, if not in your county, in adjoining counties. And so we've done some research on this, and I would say that this is just preliminary research, and I don't regard it as being the final answer. In fact, I'm a little bit embarrassed that we don't have more research information to share with you. But one of the things that I will say about this particular tool is that the way it creates the strip is not with the mole knife, not with a deep aggressive shank. It does so with coulters, and they can be various, 2 different kinds of coulters, one more fluted, one less fluted and operating deeper. But I wanted to point out that the fertilizer itself, that is essentially air driven, blown on into the soil surface as it's mixed in the zone. And so in this particular case, what you're seeing is a fertilizer application that is targeting that the upper part of that loosened area. And so that's important because it kind of fits in to what might be happening then in terms of if you were to look at fertilizer concentrations after that kind of application, and you're expecting, let's say that let's just say you're applying 1846.0 or 046.0, then you might be expecting that banding is going to give you large increases at, let's say, the 2 to 4 or the 4 to 8 inch depth. And so I hate to disappoint you, but in the early spring, after, let's say, a fall broadcast application, or fall banded application, there is literally no change at the 2 to 4 inch depth. So that banded P205, the good news is we've not left it on the surface. The good news is we've incorporated it into the soil. The good news is we've left all of the residue cover between the rows to prevent soil erosion and the soil transport of that higher phosphorus content soil, and especially, you know, we've dealt with the soluble phosphorus question mark from an environmental point of view. But if you're thinking in terms of phosphorus availability, you need to be thinking about the availability to the corn and to the soybeans. And so the position of nutrient banding is determined in the short run by the actual placement that the strip tillage tool actually achieves. And then we need to be thinking from the plant perspective in terms of just what this means for the nutrient requirement by those corn plants. And this is some older work where we looked at different nutrients, and we had 3 plant densities for corn. We had 22,000, 32,000, and 42,000 plants per acre. And the top line of boxes here is for phosphorus. And the arrow here refers to how much of the phosphorus is in the corn plant at flowering time. So the corn plants are silking away, and how much phosphorus still needs to go into the corn plant after flowering. And so what this suggests is that basically after flowering, and especially at higher plant densities, more of the phosphorus needs to go into the plant yet, because most of the phosphorus in a corn plant at maturity is in the grain. Perhaps 80 or 85% of the total phosphorus in a corn plant at maturity is in the grain itself. And so when we think about phosphorus management in corn production, we too often think only about, you know, avoiding purple corn early in the growing season, and perhaps we think about our early planting situations. We think about the susceptibility of perhaps corn under cooler soil temperature situations, but when it comes to phosphorus uptake, I really want to emphasize that it's, you know, it really takes off V5, V10, you know, V15, R1. So it really ramps up in the period around and after flowering. And so when we're thinking about the availability of phosphorus, we're thinking a little bit about the early season availability, but we also need to be thinking about the availability all season long. And that's one of the reasons why with strip till, we don't always pick up a benefit from a relatively shallow banding in a strip till program. So here's some research that was conducted on this silty clay loam soil. The average soil test phosphorus was about 25 parts per million. So we were well above the critical level. The critical level for our soils would be about 15 parts per million. And so here's a situation where we're planting corn in the corn-soybean rotation. We're not applying, we're applying our phosphorus here with or without a starter fertilizer. So here is a strip till alone. We don't have any broadcast phosphorus in this particular situation, but in here we've got a situation where we've got the combination of strip till plus the zone banding of 0.460 at the time of the fall strip till, and these are the yields. So you could say, okay, so in this particular case, you know, we're gaining about 6 bushels per acre from that banded application when we also add 1034 starter on the planter. But in the situation where we have strip till alone, and we just look at the benefit from that banded phosphorus, we don't see any particular yield advantage, just a 2 bushel advantage here. And in the springtime, that's another opportunity to do strip tillage, but it doesn't necessarily mean that that's appropriate to do on your soil. And so I'm a little bit reluctant to recommend spring strip tillage, especially on clay or clay loam soils. I'd be more favorably inclined to have strip tillage as a practice on loam and on sandy loam soils where the soils are going to be drying sooner and where there is a better opportunity to maintain friable conditions. So in terms of just sort of some comments here, is that, okay, if we're nutrient banding with the strip tillage operation, we can increase phosphorus, and in our other work with potassium, we can increase potassium concentrations. But if we really want to position that nutrient where it's most available for the whole season, and particularly for later season requirements, which phosphorus is so dependent on, then we need to be thinking about what sort of tools are we using with strip tillage operation, how deep are they going, and what is the timing, and how mobile is that nutrient. And of course, phosphorus is even less mobile, whereas something like nitrogen is highly mobile. In fact, often too mobile because we're losing it to the environment. And then the other comment I'll make, and this is something that still needs to be done in research, is basically to look at, in a long-term strip tillage program, should you always be enriching the same band, or should you be shifting your row position? Let's just say you're in a corn-soybean rotation. You plant corn in 30-inch rows, you plant soybeans in 15-inch rows, and you're using no-till for the soybean. So if you're a strict corn-soybean rotation and you come back with a program where you're fertilizing before corn, and you are perhaps, you know, using your RTK, and you are positioning the corn row exactly where it was 2 years ago. So my experience over time is that in lower testing soils, it particularly helps to move that row position so that we get more benefit from the strip till band in a horizontal shifting situation. So this is something that clearly needs more research. And then to deal with the question about whether yields can be maintained if we have, and I'm going to, just in the interest of time here, I'm going to skip by the earleaf concentrations and just focus on whether yields can be maintained with lower rates. This was some master's thesis research done by Lauren Schwartz. And again, we used the Soil Warrior, and we applied fall Soil Warrior with 0, 100, and 200 pounds of a potash type fertilizer. And this is spring Soil Warrior with the same approach. So in the first year of production, it looked like, okay, maybe we can cut the rates in half with this potash application program. But then we went through soybeans, and then we came into year 2, and now it looks a little bit less likely. In fact, if we go back to growing corn here, and we still have that reduced rate, then perhaps we're not getting as high a yield. And so the difference here was about 9 bushels per acre. So I'm a little nervous about cutting rates, whether it's phosphorus or potassium. And I'm especially nervous when the soil test levels down to the 6 or to the 8-inch depth are in the moderate to low range. And so these were some of the soil test situations to the 8-inch depth in these situations. So be careful on the rate reduction side of things. Some of the best work on phosphorus placement has been done in Kansas by Dorivar Diaz. He used a shank type delivery system, used a rolling basket to help shape the berm. And he has a number of papers where he looks at comparison of broadcast versus deep band. Maybe I should stop here for a moment, just ask Chris, how many minutes do I have left? Because I tend to get carried away and I want to sort of respect the audience as well as the organizers.
Yeah, maybe time for just a couple more slides, Dr. Van, and then we'll have hopefully some time at the end for.
Right. No, that's good. So this is, I'll just basically say that he compared broadcast to deep band, but he also compared broadcast plus a starter and then deep band plus a starter. And so the early uptake suggested that, hey, you know, with deep banding, we're doing better in total phosphorus uptake. And this was around the V6 stage. So at the V6 stage, we would pick up some benefit. But then when it came to the actual final yields, there was no benefit for the deep banding compared to the broadcast application. Now, from an environmental point of view, we should be deep banding, okay? I mean, make no mistake about this. There's no way that we should be broadcast applying the phosphorus. But I do want to make the point that in low soil test situations, low soil test phosphorus, there sometimes can be a benefit from a broader distribution than just from a single deep band application. And that's true as well for the soybeans which follow, even when the soybeans are planted in the same row zone. So there can be a tremendous response to phosphorus going from 48 bushels to 63. And it helps if there's been starter as well in terms of the following soybean yield. So we can have a situation where we don't always pick up a benefit from the deep banded situation. And that's particularly true in situations where we have really it's particularly true in situations where we begin with low soil test. Now, I'm guessing that for the most part in Illinois, you're successful as a farmer today because you've kept up your overall soil test phosphorus. And I would encourage you to be thinking about using strip till as a way of improving the plant-to-plant uniformity. I've been arguing for a long time that we should always manage our crop with the concept of no plant left behind. And one of the things that we can do with having deeper banding of phosphorus as well as potassium is to allow equal nutrient access to all the plants in a row, even if they are grown at high plant densities like 42,000 plants per acre. So finally, there's a lot to the story about this placement question with strip till, but I really want to and there's a lot more research that needs to be done and hopefully will be funded in the future to answer some of these questions that farmers have. We definitely need to place it in the soil sometimes there's some question about how deep it should actually be. And sometimes there's question about how wide the soil zone should be that gets that nutrient enrichment. But I think it's really important to say, hey, we can get higher yields with strip till even by itself. We're pretty reliable after corn and after soybeans, and but we need to recognize if we're going to combine strip tillage with nutrient banding, we need to be thinking about where that nutrient distribution is actually placed. And that's especially the case if we have low soil test plus severe stratification. And finally, we're not exactly sure whether we can always eliminate starter nitrogen and phosphorus just because we have banded those nutrients with pre-plant strip tillage. So I want to acknowledge some of the companies and government entities that have supported this research over the years, and I particularly want to thank the graduate students that have made all of these measurements possible. And I want to thank you for your time today. So with that, I'll leave it back to Chris and invite questions or comments.
Well, thank you, Dr. Vine, and we'll be, I think, some great content there, and we've got a few questions coming in already, and we'll get to those hopefully at the end of the program. So at this time, I'm going to turn it over, the screen share over to Dan Schaefer. Dan is the Director of Nutrient Stewardship for the Illinois Fertilizer and Chemical Association, and prior to joining IFCA in 2012, Dan spent 30 years in the ag retail business as an agronomist and plant manager for Illini FS, and where he worked directly with growers on improving their yields through agronomic practices and recommendations, and also assisting the University of Illinois with on-farm research to improve nutrient efficiency. Dan has a Master of Science degree in agronomy from the University of Illinois, is also a certified professional agronomist, certified crop advisor, and a 4-hour nutrient management specialist. In 2010, Illinois Farm Bureau named Dan the CCA of the Year, and Dan and his family reside in Tolono, Illinois. So Dan, welcome to the program, and thank you for joining us today.
Thank you, Chris. Can you hear me okay?
I can, and I don't see your slides just yet.
Oh, really? Let me back off here. Yes. How about now?
Still nothing.
Well, I'm not sure why they're not coming up, Chris. Can you key in what you've got on me? Because I'm bringing it up, and
yeah, we can have Jean pull those slides up.
Yeah, so right now, Dan, we just see your face. We're not seeing your slide share at all. But I do have your slides if you want me to just pull those up and I can run through them.
Yeah, I'm not seeing where to. I clicked on where it's asked me to share, and I don't see them coming up.
That's not coming up. Okay. Do you want me to just go ahead and pull your slides up on my end?
Yes,
and you
please.
Can just tell me when to advance. Perfect. We'll do. Let's see. Does that look right?
Yep, that looks good.
Great.
Thanks, Jean.
So Jean, go ahead and advance to the next one. So most of the research that we do here in Illinois is funded by the Nutrient Research and Education Council. So everything that I work with comes from the funding of 75 cents per ton on fertilizer products sold. Another 25 cents actually goes to the Department of Ag for monitoring the program. Go ahead. So nutrient loss reduction strategy goal, reduce N and P loading to the Gulf by 45%. We've got a target date coming up in 2025, 15% for N, 25% for phosphorus. That's coming up pretty fast on us. We need probably some changes made to maybe hit that. Go ahead. Nutrient non-point sources, nitrate, tile drainage is the predominant source. Very little overland runoff. Nitrate is low in precipitation. Nitrate's not on the surface, but phosphorus, the overland runoff, is the predominant source. Soil erosion, unincorporated P fertilizer, and a little bit in tile drainage. It's not totally clean, okay? So the nutrient loss reduction strategy, I call these some of the easy buttons, include many of the 4 R's: maximum return to nitrogen calculator, the calculator that we've been working on for the last 10 years. We know what the nitrogen rate in Illinois needs to be. We've got the right rate pretty much figured out using the calculator. Use of nitrification inhibitors, strip till deep placement. I think this is a huge one. I totally agree with Tony on his points on that. We've got some research that he's talking about already done in Illinois. Dr. Fernandez did some of that work with us for 8 years, and there's several papers been written on deep banding and whether or not you move the band around. The big one that we talk about a lot is no frozen or snow covered phosphorus applications in the winter. That's a huge one. I'm going to show you some information here later on, or talk about some in the presentation. Filter strips and buffers, but a big one that needs to be at the top of the heap here is cover crops. We're finding with our research in Illinois that cover crops go a long ways to improve tile water and surface water quality. Okay. This is the strip till bar we're using in some of our research. This is a corn on corn plot. We are doing deep placement trials with this. The nice thing is, as Tony talked about with strip till, when you plant those strips in the spring, it's like planting into a garden. Okay. These are going to be, I'm going to go through these fairly quick, Gene. So this is just showing an up close view of strips made in a cornfield, whether you're going corn on corn or you're planting 30-inch row beans. I think there's a big benefit to using the strip till bar as a tillage tool rather than chisel plows and leaving the residue on the surface, utilizing strip till. Okay. This, like Tony talked about, we lack some research on strip till and replacing tillage practices, full width tillage with strips. But this is a planted field after the strips were made in the fall. And when you got a 0 to 2% slope, this works very nicely. And most of the tile drained areas here in central Illinois would benefit from utilizing strip till with very little chances of erosion of those strips. Okay. Now, one of the research farms in Douglas County we're investigating depressional areas and investigating P hotspots within a field. This grainy photo Lowell Gentry found is from 1946. And this farm that we're on in Douglas County is a 300-acre farm, and down along the North Road, we suspected a farm site. Well, the phosphorus and potassium readings are really high on this, but you can see where the barns are located. And then off to the east side of that would be the some of the pastures and stuff. And as the university researchers have gone, they've soil tested some of this, and they've shared some of that information with me. Go ahead. This map, these are depressional areas where you see the blue in there. Those are like 2 to 2.5 feet depth of depressions within this field. It's a Milford soil in Douglas County. This is the barn lot, and some of these readings here are 180 to 385 pounds per acre soil test P. These are depressional areas, and most of these run somewhere in that 100 to 180 pounds per acre of phosphorus. And this is just clearly kind of makes the case for utilizing variable rate applications to take advantage of high phosphorus where you don't need it, but also probably improving water quality, because down deep, they've tested the tile lines that are under this farm. This farm has a complete tile system, and we are pulling phosphorus out of those depressional areas. The phosphorus is down around the tile. Okay. This is the variable rate map of the field, and you can see that these are 0 phosphorus application areas, and you can see the depressions by the darker colors. And this is the edge of that farm lot, and this is another depressional area, but these are areas where no fertilizer is really required. And knowing the farm, this is a very wet area that, even though we got tile drainage, there's poor crop production. So the variable rate application would address that by not applying phosphorus to those areas. Okay. So kind of a summary for those phosphorus results. Soil P is related to the tile DRP losses. Actually, in our strip till last year, 2 weeks after application with our deep placement, they did catch dissolved active phosphorus in the tile lines coming out. We had a higher blip in the treatments where we had deep banding versus a spring application, and that lasted for about 6 weeks, and then it settled back down. So we can get some losses, especially where you've got higher phosphorus levels. The closed topographical depressions are important for DRP leaching. Legacy P just persists for decades. I showed you that picture in 1946, and we're now in 2021, and look at what we've got for soil test results. Targeted soil sampling strategies on that farm. We have started, we do a 2.5 acre grid, but we also do the depressional areas at about a 1 acre grid. And it pretty much says variable rate fertilizer phosphorus applications will pay on that type of farm. Economically, it's a good thing to do. And again, a reminder, do not broadcast on snow, do not broadcast on frozen soils before a predicted rain. Okay. So this is January, around January 1st of 2019. We had a heavy rainfall event in Champaign County, and the ground wasn't frozen. This is an area that really needs a waterway in the worst way. And this is an erosion, a soil movement rainfall event. Fertilizer wasn't spread recently on the field or anything, but I'm going to show you some results in the Embar River from this event that Lowell Gentry and his group have been traveling to that same site for 25 years and have a long history of collecting phosphorus data from this. Next picture. This is a later picture after the rainfall event, and you can see the erosion. Now, what happens to this farm, and this just begs the need for waterways. What happens every spring, the guy that cash rents this farm comes in with his field cultivators and works it and gets it leveled back down again, and so he can plant it. And then the reoccurring thing is we move the sediment in the soil off of this back across the road, and you can't see across the road because I should have taken a picture of that waterway, but I didn't. The guy across the road told me in 2020 he had to replace the waterway. They had to clean it out and then reseed it. So all this sediment soil is moving somewhere. Okay, go ahead. This is just down the road from that same farm, and this is a picture from March 9th, 2019. We had a week of frozen weather, frozen soil that week. We had real cold temperatures. We were able to get back out in the field, and a lot of fertilizer was being spread at that point in time. During the day on March the 9th, we received an inch of rain in a very short period of time. And the picture is a little bit late, but this is where I took some water samples at about the peak, not quite the peak of the flow coming off that field after it'd been spread with 250 pounds of MAP and 250 pounds of potash. And the water sample I collected, analyzed, was 19 parts per million phosphorus and 30 some parts per million of chloride. But the untreated fields that we tested were 0.3 of a part per million. So 19 parts per million off this field versus 0.3 of a part per million. Besides the loss of the fertilizer and the dollars, there was about 10 pounds of P2O5 we estimated came off this. We didn't have any way to gauge the flow other than kind of guess at it. But the other thing that comes into mind, this field was spread. Where did the fertilizer move to? So you spent money for fertilizer that actually ended up probably being moved to other areas of the field. It no longer is a very even application. Go ahead. So this is the, I need to get rid of this. Whoops. Now what happened, Gene? There we go. I was trying to limit that pain over there. But anyway, so this is dissolved P concentrations at Camargo, Illinois, for phosphorus. And 6 out of the, we got some dates there you see across that graph. 6 out of the 8 flow events with greater DRP were snowfall melt events. 11-17 and 11-19 were actually a sediment soil erosion event where phosphorus was picked up in the river. And I told you, and I showed you that picture of 11-19 of that soil erosion. That's where that soil ended up into the Embrawl, and then on down ends up in Lake Charleston, and just keeps on going down to Wabash and the Ohio and probably in the Mississippi. Then on that 3-10-19, that's a dissolved reactive phosphorus event from that sample. That's the timing of those samples I pulled out of that field that had just been spread 3 days before the rainfall event on the 9th of March. So you can see sure, that was one field, but multiple fields are being spread. So we can see the impact we can have if we're not watching the weather on spreading events. The 21st of February in 2014, I remember that too. We had a lot of deep snow, and a lot of spreading was going on at that point in time, right prior to that. So when we say don't spread on frozen snow-covered ground, this is the reasoning. I mean, we know we're moving fertilizer around, phosphorus around, but we're also losing fertilizer into the environment. And I don't think, that's what we really want to do. Go ahead. That's what a nice waterway would look like. That would be a nice waterway to put in that spot where I showed you the gully erosion. Go ahead. Cover crops. So I talked about cover crops. We're doing a lot of research as far as nitrate goes, with cover crops being able to sequester nitrate on some of the fields we're researching, but also it does impede the movement of water across the field. This is not a real heavy, this is an early spring picture of a cover crop field, and it actually does slow the movement of water trying to go across this field, and anything will help try to hold that soil in place. Go ahead. Anybody wants to know what Lowell Gentry looks like out in the field? That's him right here. He's pulling biomass samples out of cereal rye cover crop that was planted that was drilled into corn stalks. And if you want to know what basically what a half ton of biomass looks like, that's about what it looks like from cereal rye early in the spring. His research is showing it takes about a half a ton of biomass to start affecting tile nitrates coming through a field. So it just gives you an idea of where you can start terminating. You've done some good by having the cover crop out there. Next. That's just a picture of the same field, and that stake gives you an idea that's about 6 to 8 inches tall with the cereal rye cover crop. Strips in that would look great. Strip till that, plant your corn or plant your beans into it, and you'd be in really good shape. Go ahead. And this is just a picture of a cover crop field after the spring burn down was done. It had fall strips put in it, and talking to the guys that we do this, and also some of the guys around here do that. And it's like planting into a garden. Basically, that strip is very plantable. It's plantable early in the year, early in the spring season, and emergence, just like Tony said, it's like a picket fence out there when you do it this way, because your depth control on your planters works really well because you've got a surface that is very consistent. So we've been really very pleased with utilization and using strip till. Unfortunately, in Central Illinois, the change over to strip till has been very slow. Go ahead. Phosphorus moves with water. So we've got here on This side of the screen, we've got a nice buffer, keeping phosphorus from getting over into the stream or the drainage ditch. Over here, we've got a drainage ditch that chisel plowed right up to the very edge of that. And as a past fertilizer retailer, it's hard to spread fertilizer in a field like that, and you got to hang back a ways to keep from spreading phosphorus right in, directly into the drainage ditch. Go ahead. This field, I took this picture just yesterday, but right along here, this is corn. This is a drainage ditch. Right along here is the cornfield. I don't even think I could walk along there without rolling down into the ditch. 2 years ago, this had a 60 to 80 foot CRP buffer along the edge, and most of this is spoils from dredging the ditch, so it's not real productive ground. It raised really good grass, and there wasn't any weeds in there or anything. And but they chose, when they came out of the CRP program, to plow that sod up and then plant right up close to it. It really needs, something like this really needs that buffer put in. Go ahead. So I'm going to talk briefly about some of the work we're doing down at Douglas County, monitoring the 36 tile site. We got agri-drain structures. We got pressure transducers, water sampler. This is a water sampler. It pulls the water up out of the agri-drain structure. And we're getting analysis of nitrate, ammonium, phosphorus, and potassium. Go ahead. That's what it looks like on the inside. If everyone know what it looked like on the inside of one of these, that's the agri-drain structure. That's a V-notched weir down there out of the stop log. That's how they calculate pounds per acre. So besides having just parts per million, this project and most of the projects we're on actually calculates pounds per acre of movement. Go ahead. The main reason for showing this graph, this goes all the way out to 21. This blue line here is the influence of cover crop across there. And so when you look at that, you can see the difference. Now that's a 50% pre-plant followed by 50% side dress with a cover, and then the 50% that its pair is the yellow line, and it's fairly low. Unfortunately, if you look at the black line, especially where the corn is planted, you'll see the fall nitrogen is the leakiest part of the system. Once we get into spring and we apply nitrogen, those systems are leaky also. Go ahead. I'm just going to show this real quick. This is corn stalks with no cover, and what I'm talking about here is the residue left from a crop makes a big difference on how much nitrogen you lost. This is a high carbon. Corn stalks are highly carbon. The carbon to nitrogen ratio is very high. Very little leaking of nitrate, less than 4 parts per million. But then the soybean stubble, the soybean residue, is very this is all prior to fertilizer being applied. The soybean stubble is very fragile and breaks down quickly, and it's also has a low carbon to nitrogen ratio. And actually, the nitrate loss there was 16 pounds per acre in 2018. And we was able to measure that because we didn't have any fertilizer on there. Next, just shows that I'm just showing the difference here between the cover. This is a 4-year graph on nitrate loss. The cover is down at about 60 parts per million. The 100% in the fall is up around probably 115 or so. Go ahead. I think my 20 minutes are up. This is the Illinois corn N rate calculator for 2021. You can see your average nitrogen rates, what they would be, your starting point. You'll notice it's Southern Illinois. We've raised that over the last couple of years. Southern Illinois does need, with their low organic matter soils, do need a little more nitrogen than what we do in central and north. Go ahead. You can go to Illinois Fertilizer and Chemical Association website, click on Keep It For Our Crop, and you can see all the N-rate trials we've done for the last 9 years, and you can see the response curves. Go ahead. Is this a BMP? Is this the right time? Is this the right place? I argue no. There's got to be a better time and place to apply nutrients. maybe even not, if we can't get them applied ahead of planting. Most cases, soil test P's and K's are high enough, we could put it off till the following fall and get them spread then when it's not going to run off. Go ahead. Last March, I talked to the farmer that was having the retailer spread this. Actually, he was stuck in a ditch, and I had to pick him up in my pickup and take him back to his house to get another tractor to pull him out. And I asked him, I said, why are you spreading on this snow like this? And I gave him my business card, and he said, oh, you're probably not very happy with me. And I said, no, not really, but why are you doing it? And he said, basically because I don't want the wheel tracks in the spring. And so that's why he was, and he argued to get the retailer to do the spreading. Go ahead. And that's my time. And anybody has any questions, you can call me or email me. And when I was back in the fertilizer business, if I didn't answer my phone, my customer complaints kind of went down. Thank you.
Thank you so much, Dan. Some great information there. Looking forward to a few questions and some additional comments later. So at this time, I want to introduce Bill Hyan. Bill is a farmer in the Upper Macoupin Creek watershed. He's been a member of the Upper Macoupin Creek Watershed Partnership Steering Committee for several years. And just like to introduce Bill. A lot of the practices, Bill, that we've been talking about today, you're utilizing on your farm. So if you don't mind, tell us a little more about your farm operation and also what you thought about the presentations today.
I think he's muted. Yeah.
Sorry about that. Am I on now?
Yep, you're good now.
Okay, sorry about that.
No worries.
So we're based out of Gillespie, Illinois. We farm mostly southern Macoupin County and do about 2,500 acres. Currently, we are 100% strip till corn. We do a large portion of our soybeans have cover crops ahead of them. Doing some cover crops ahead of corn, kind of messing around with that. Still a learning curve there. Do a lot of split nitrogen applications and a few other conservation type things that we're trying to implement for better soil health programs and environmental stuff. As far as the speakers today, I thought Tony had a lot of good stuff that I completely agreed with when he was talking about the strip till. Some of the takeaways that I pulled out of there that I agree with. The biggest yield benefit that I see from the strip till is the earlier planting date. We can get in and start planting when everybody else around is trying to get in hydroson or trying to get, groundworks. I'm heading to the field of the planter. We don't have to mess with any of that. And our reduced labor with the strip till has been a big thing for us, just because we're limited on labor here for me. I'm not really a big fan of the lowering rates as far as the fertilizer rates with the strip till. I think from a yield standpoint, you can probably get away with it a year or two here or there. But I think from a soil long-term fertility, I don't think it's a good idea to be backing rates off. And I do agree that moving the row shift, we try to move every corn year, we shift over 15 inches. So we're moving that strip, and then we actually spread ahead of beans as well. So we're putting those in between. We're on 15-inch beans.
Bill, can you talk a little bit about your nutrient management program? What nutrients you're putting down with your strip till bar, and then also your nitrogen program. Sure. Ahead of planting, during planting, after planting.
Sure. Sorry, I got a little wordy there. As far as our nutrient plan, we're putting down fall strips. Typically, I'm putting my P and K with that. Depending on the farm and the yields and things, we adjust rates, but we're typically running somewhere in that 150 pounds of DAP and 100 pounds of potash. Would be kind of a typical on strip till, and then we make up some differences on beans when we come back or when we spread ahead of our bean crops. And then as far as our planting and nitrogen, we're running a 2x2x2 nitrogen system on the planter, along with an in-furrow starter. And then we come back later season, V8 to V10 with a wide drop for the remainder of our nitrogen. So we've gotten completely away from anhydrous and have seen some yield benefits, I believe, just from that nitrogen change alone.
So other thoughts about today's presentation, Bill? I know, we talked a lot about, some of the phosphorus hotspots in other parts of the state. In the Upper Macoupin Creek watershed, we have, we identified a large concentration of water and sediment control basins. And, I want to also invite Dan and Tony back to this discussion as well, and thinking about those water and sediment control basins are certainly needed to control erosion, and but is there any research out there that's also showing them as potential hotspots as we get concentrations of sediment that are going there? And maybe just talk, Bill, about your experience on your farm with basins, and if you're doing anything different in your application rates in those areas.
I am not really doing difference in application as far as doing the VRT or anything like that. We've got some sediment strips, I guess, along some creeks, things like that, where we're putting grass strips in. And for me, there's twofold on that. Number one, we're trying to stop erosion and runoff and nutrient loss, but I'm also trying to straighten up edges, because the more straight lines I have for strip till, the better it works. So that's kind of, as the guy that runs the planter, that's my benefit to it that I see big time. So, and as far as the research, that's probably more in Tony or Dan's field than mine. So.
Well, I think that when it comes to hotspots, Dan had some interesting slides that he presented on sort of the history and what it might mean in terms of contribution. And so I'm going to defer to him, but I will say that it's really important to know from year to year where you're placing that phosphorus, and having the opportunity for RTK guidance and knowing where you're going to go in subsequent years is really helpful from the standpoint of distributing nutrients that are essential for corn in more of the rooting volume. And so when I think about optimum corn management, yes, I mean, here this program is all about, looking at deeper banding, but it's also true that when you look at what does the corn plant benefit from in the long term, it benefits from a more extensive nutrient availability in its whole rooting zone, and not just in the first, seminal roots that come off of the corn plant.
So I agree with Tony on distribution of the fertilizer throughout the rooting zone. One of the things we found out from a 8-year study, and I'm sure Tony's seen the results from Fabian Fernandez and the work we did in Illinois, was that if we continued putting that band in the same spot, and we did a rate study, we had 7 rates, we depleted the between row positions. So if you continue to band in the same spot, you can start to hurt your yields from doing exactly that. You deplete I guess the way I'm trying to say this is the roots investigate the whole soil area. They go through they go down, they go across, and they're pulling fertilizer and nutrients and water, basically water too, from the whole profile. So, but still, having the soil test information is, I think, is critical to anything we're going to do. And then if you got some depressional areas, like I mentioned earlier, do a smaller grid in those areas and incorporate those into your fertility plans, because you can benefit from not spreading those areas where there's P1s of 70 or 80 or 100, and then concentrate on the areas that are high yielding and probably have lower phosphorus and potassium soil tests.
So Bill, I know, you had tried strip till several years ago on the farm and really have made the transition to all strip till for corn in the last couple of years. How important was the technological advances in being able to do that in the last couple of years?
I think the auto steer was huge, and going to RTK made it even better. We actually had our first strip till bar in fall of 06. And I think I had a light bar at that time and markers on a strip till bar. And then trying to come back and plant on top of it with a planter was kind of a challenge, because I can't drive that straight without the auto steer. But now the quality of the systems that we have today and the technology we have makes it awful easy to hit that button, have perfectly straight rows, and come back and plant on. Our planter does not match our strip till bar as far as width, even close. So if I didn't have that, that'd be impossible to do today, to run a large planter with smaller strip till bars. So
I think, Tony, you've got some data that shows if we're not on the strip, there's a yield penalty, right?
Yeah, the yield penalty can be sometimes as much as 10 bushels on corn if you're off the center of the strip by 3 inches. So, I mean, it really makes a difference, and it's complicated a little bit as well that's just the straight soil physical benefit from the warmth, from the friability, and from the uniformity of seed placement. But if you're also, thinking in terms of a nutrient banding at the same time, then the benefit from being, precisely, in that specific row position relative to the band can be even higher than that. And I'm kind of, curious, basically in Bill's program, and just maybe you could, you've got some nice pictures there in the background behind your behind your face, but basically tell me what the number of strips on the strip till bar is versus the planter, and how that's been working out for you.
We run a 16-row strip till bar. We got a King Kraus, a Gladiator that we're putting on dry fertilizer with, and a deep band. Okay. And then we actually run a 36-row planter. So like I said, I'm taking 2 plus a few rows widths of my strip till bar with the planter. But planter was just we didn't really want one that big, found a deal on it kind of thing. And but I like it now that I've got it, because I got less point rows or pinch rows, excuse me. So we've kind of eliminated that, and I've seen some yield advantages just from the planter size, if that makes sense.
Right. That's and how many wheel tracks are you using on the? Is it a normal power tractor or a track that you're using to pull the planter with?
We're actually using a quad track tractor.
Okay.
And that's the same tractor I pull my strip till bar with. So all my patterns and everything are in there, and it just makes it simpler in that regard. Plus, with all the tanks we're carrying and stuff, it takes some power to pull all of that.
That's interesting. I mean, I think there are more questions to come down the way, and one of them that I'd be interested in, especially in Central Illinois, is kind of what are we thinking about the future of corn stalk residue processing at harvest time, and whether we're thinking in terms of stalk chopping or not, and that has implications as well for nutrient distribution, as well as the ease of putting new strip till zones in a particular position relative to an old row. Now, it matters less in a corn-soybean rotation, perhaps. But I do know that there's a lot of interest now in doing something more with with corn stalks because of yield levels and because of higher plant population densities.
If anyone has any questions, feel free to put those in the chat, or if you'd like to just unmute yourself and ask those questions. We've got a few minutes here left for some questions.
I got a question for Bill. When you were getting ready to move into strip till, who did you find help with to help you decide on equipment and help you to understand your fertility program and those kind of things? Were you pretty much kind of on your own to figure it out, or did you have somebody helping you?
Yeah, we were pretty much on our own. From my dad and my brother, so it's a joint decision most of the time. And actually, when we first started, our first strip till bar was in fall of 06 with a Case IH bar with a cart in between, and it was kind of it worked, but it wasn't a great system. But my dad and brother went to a meeting, and they come home, and they were ready to buy one and go all gung ho, and we did for a couple of years. But I was a little more hesitant, I guess, just old school, thinking, and then I had to run it too, and I had some issues with that system that didn't quite work out the way I wanted it to. So it's been a progression. I mean, we've done a lot of strip till, we've got a little bit away from it, and then we're back. Like I said, now the last several years we've been 100%. So I don't know if that quite answered your question or not, but
yeah, it did. But it leads us to the question: is we need more outreach to help farmers that want to make this transition. We need experienced people and researchers like Tony to talk to groups and help them make this decision. It wasn't a cheap decision for you. I mean, economically, it's benefited you, but it also, as far as equipment and that kind of thing. So, somewhere along the line, I think we need to get, excuse me, we need to get people engaged to, help farmers that want to make this decision, maybe small groups and things like that, but somehow have demonstrations, I guess, or something like that. But I don't know what I'm looking for there, but people need to have somebody they can go to and talk to.
Sure. And we've done some of those kind of demonstrations and things through Chris and some of our other local groups where we've ran the machine, with at a meeting or whatever. And I'm always available. Anybody wants to talk about it, I'm willing to, talk about it. Or we do about 1,000 acres of custom work. So if a guy wants to try 40 acres, we'd be willing to come out and work with them and help them make decisions and stuff to go with it. So.
Yeah, and Bill, you also worked with, M&M Service Company for several years. We had a program with a soil warrior. We actually had 2 soil warrior strip till bars in the watershed, and working through M&M Service Company to do some of that custom strip tilling. And I think that program is really successful. Maybe not successful for selling the soil warrior strip till bar, but certainly there were several farmers that have adopted strip till like you, Bill, that are in the watershed that participated in that program, gained a little more comfort in strip tilling, and ultimately went out and made that investment for that piece of equipment. So I think that was a nice bridge for a lot of farmers to go from wanting to try it out, seeing how it would work on their farm to eventually making that investment. So certainly was a successful program from that perspective.
Well, and you talk about investment. I mean, I think the strip till bar is a big investment. They're not cheap by any stretch of the imagination. But if you compare it to owning disc rippers and field cultivators and all the other tillage equipment that you'd have to have, which I've still got some of that stuff that's an older, leave it in the shed, it'll work if we need it kind of situation, but I don't have to update that stuff anymore. And our fuel costs have gone down so much, we probably have reduced, we don't have or one less tractor than we would have if I had to have a tillage tractor all the time, you know, and a big tillage tractor is expensive. So I think actually your total investment once you go to that system is probably less, and your fuel costs are tremendously less. Our fuel bill this, you know, the last couple of years have been so much lower, you know, and I think there's a big cost benefit to it as well, you know, that you don't necessarily see right at the very beginning, but once you're in the system, there's no doubt you're saving a lot of money on those kind of inputs.
Well, I just want to wrap things up here in the last couple minutes. So, you know, Dr. Vine, Dan, Bill, thank you again for joining us today. I think Gene will be sharing contact information. If anyone has any further questions after the program, we'd be happy to help, you know, answer some of those questions. We're also going to include a link to the research papers that were mentioned today, and for those that are wanting to learn more. Also, there was a comment in the chat about the Precision Conservation Management Program. Some excellent information there that also points to some of the economic advantages to strip till. So please feel free to check that out as well. Just also want to thank some of our partners in the watershed for financial support and their partnership, the National Fish and Wildlife Foundation and the Mosaic Foundation and the Walton Family Foundation. So thank you to those folks that have been working with us in that watershed, in the Upper Macoupin Creek watershed for many years. Also, if you're a certified crop advisor, please, if you have the Certified Crop Advisor app, please go ahead and feel free to scan for those CEUs today. If you don't have the app, feel free to put your CCA number in the chat for Gene, and we'll make sure we get those reported. So again, thank you all. Gene will be putting up an exit poll here shortly. Feel free to fill out that exit poll, and thank you so much for joining us today.